So the next concept in backtracking is sum of subset. Now here the problem statement is there is a S set given consisting of n number of integer values. These values are in ascending order. We have to find a subset from the given set whose addition comes out to be a value d. D is given to you. A set of integers is given and a value d is given. We have to find out subset from this such that the addition of this subset is equal to d. Now these are arranged in ascending order. That means s1 is less than s2 or equal to, you can say, equal to s3 less than equal to up to Sn. So this set values are arranged in ascending order. So how to solve this problem using backtracking concept? For that we'll take the example which was asked in May 2018. Given is n equals to 6, that means 6 elements are there in the given set and the 6 elements are this way, which are arranged as you can see in ascending order, and m equals to 20 is given, that is addition is should come out to be 20. So we'll represent in tabular format. The first column is the subset, second is sum, and the remarks. Now we'll start with the first element is 3. So 3 and 5, first two elements 3 and 5, whose sum comes out to be 8. What we want? We want the sum should be 20. We have got sum as 8. So in remarks I'll write 8 is less than 20. We have not got the 20 sum. That means we have to add more elements from the set to this subset to get value 20. So what I'll do? I'll write add next element. Since we have got the sum lesser than the required sum, so I'll add next element from the subset is 7. So this comes out to be 3 plus 5 plus 7, which is 15. So 15 is less than 20 again. So I have to add one more element. The next element is 8. So I'll add 3, 5, 7, 8. Now this comes out to be 23. Okay. Now 23 has exceeded 20. That means what? This subset is not our solution. This addition of these values in the subset is giving me 23, which is greater than 20. That means this is the wrong choice we have made. Hence we are going to use backtracking concept. So I'll use backtrack. Now what backtrack? Since we know that these are arranged in ascending order, that means this choice and whatever elements are there after 8 all are wrong choices, because these all are greater than 8. So of course we are going to get the addition greater than 23. That means backtracking means what? We have to backtrack at this position, at 7 position. So I'll use 3, 5. Now instead of 7, what choice I'll make? I'll make a choice of the next element 8. So I have the sum as 16. So 16 is less than 20. Whenever it is less, I'll add the next element. Now after 8 we have 9. So I'll add 3, 5, 8, 9. So I get here 25. So 25 is greater than 20. So whenever it is greater, we always backtrack. Now backtrack means which choice is wrong? This choice is wrong. It is not giving me any solution. So I'll keep 3, 5 as it is. And instead of 8 now, what is the element after 8? We have taken 9. After 8 is 9. So instead of 8, I'll write here 9. So this will give me 17. So 17 is less than 20. So I'll add the next element. So 3, 5, 9. Now after 9, next element is 15. So 15. So I get here 32. So 32 is greater than 20. So backtrack. So backtrack means I'll change this 9. So I'll have 3, 5. Now after 9, what we have? 15. So 3, 5 and 15, which will give me 23. 23 is greater than 20. So again backtrack. Backtrack means what now? This 5. I have to change the choice of 5. So after 5, what we have? 7. So instead of 5, I'll write here 3, 7, which gives me 10. 10 is less than 20, so add the next element. 3, 7. So after 7 you have 8, 8, which will give me 18. So 18 is less than 20, so I'll add one more element. So 3, 7, 8. Now after 8 we have 9, so 9. So this will give me 27. 27 is greater than 20, so backtrack. That means this choice we are going to change. So I have 3, 7. Now instead of 8, what is the element after 8? 9. So I'll consider now 9. 3 plus 7 plus 9, which gives me 19. 19 is less than 20, so I have to add. So we have 3, 7, 9, 19. So after 9, which element you have? 15. So I'll add 3, 7, 9 and 15. So I have here 3, 7, 9, 15, which will give me 34. So 34 is greater than 20. So since 34 greater than 20, again we will backtrack. So we have, I'll write the elements again here up. We have 3, 5, 7, 8, 9, 15. So we have taken the choice 3, 7, 9 and 15. We are getting greater than 20. So backtrack means we are going to change the value of 9. So instead of 9, I am going to take another choice, that is 15. So I have 3, 7 and 15. So I get here 25. So 25 is greater than 20. So again I'll backtrack. Now this is the value which is the wrong choice. So instead of 7, we'll take the next value. Next value is 8. That means 3 and 8 gives me 11. 11 less than 20. So I'll add the next element to our subset. The next element to 8 is 9. So I'll add here 3, 8, 9, which gives me 20. So 20 is equal to 20. So this is our solution, but it is the first solution. You may get more than one solutions to this problem. So this is one solution. We have to find all the solutions to this problem. This problem lasts for 10 marks. So all the solutions we need to find. We have got one solution. Now we have got 3 plus 8 plus 9 gives 20. This is the first solution. So let's go for the remaining solutions. Now this choice is over, so we'll change this value. Instead of 8, I'll take the next value, that is 9. This gives me 12. 12 is less than 20, so add the next element. So 3, 9. Now 9 next element is 15, so I'll add 15. This gives me 27. So 27 greater than 20, so I'll backtrack. So backtrack means I'll change this 9 value. So instead of 9, I'll put the next value. 9's next value is 15. So which gives me 18. 3 plus 15, 18. 18 is less than 20. So I'll add next element. Now there is no element left over here. That is, list is ending. So I'll now backtrack. I cannot add any element here. The list is finished after 15. So we will backtrack to one place behind and we'll change this 3. Now 3 was here. So I have to start the list now subset from element 5. Instead of 3, I'll replace it with 5 and the next element 7. So which will give me 12. 12 is less than 20. So add the next element. So I have 5, 7. After 7, the next element is 8. So 5 plus 7 plus 8 will give me 20. So 20 equals to 20. So this is my solution 2. I've got the second solution. So this way solve for the till end. I've solved this entire problem in the PDF file. you can refer that, as well as I've solved all the question paper problems as well in the PDF file. Now from this, again, just as we have drawn the state space tree for the term n-quint problem, we have to draw the state space tree for the sum of subset problem also. So we cannot draw the entire state space tree always. In the paper also, you are going to draw the partial state space tree. Okay, now this same example we'll take. Now here in the state space tree, I am going to use the abbreviation I and E. I indicates include and E indicates exclude. So I'll start with the first phase, that is my sum is 0. Initially my addition of the subset is 0. Now I'll start with the element 3. First, on the left hand side I'll write I3, the right hand side I'll write E3. That is include 3, exclude 3. When I'm including 3, I get the sum as 3. Include means where we are including in the subset. So in the subset, if I include 3, I get the addition 3. Now after 3, what is the next element? 5. Okay, so here I can include 5 or I can exclude 5. Again, if I include 5, I'll get 3 plus 5 sum as 8. If I exclude 5, I'll get the sum as it is 3. Now here again, after 3 and 5 you have 7. So here again include 7 or exclude 7. So if I include 7, I get 8 plus 7, 15. If I exclude 7, I get 8 as it is. Okay, so always there are two choices, include and exclude. So here also, go on solving this way. 3, 5, 7, the next element is 8, but we have to find out the sum is 20. We are requiring m equals to 20. So you know that after 7 the next choice is 8, which is going to give me greater than 20. So we'll stop here because this is not going to give us the solution. So we'll stop here. Now this will continue. We have considered 3, 5 and 7. We have finished with 3, 5, 7. Next element is 8. So here include 8 or exclude 8. If I include 8, this will give me 16. If I exclude 8, the sum is as it is. Now after this we are not going to get 20 because after 8 you have 9. 16 plus 9 is 25. So we are not getting solution here also. Now if we come here, after 8 what we have? 9. So here I can include 9 or exclude 9. If I include 9, I'll get 17. If I exclude 9, I'll get 8 as it is. So here also I will not get solution. Here also I will not get solution. Now let's go here. Now here we are 5 and 3 is over. 3 and 5 is over. 3, 5 is over. Now we'll make another choice as 7. So I can include 7 or I can exclude 7. Include 7 or exclude 7. If I include 7, I am getting 10 answer. 3 plus 7 is 10. Exclude 7, the sum is as it is 3. This way you solve it. I'll solve this part, I'll leave this part. So here we are see 3, 5, 7 are over. 3, 5, 7 are over. Next element is 8. So here we can include 8 or we can exclude 8. Okay, if I include 8, I will get here the sum is 11. Now after 8 we have 9. So here I can include 9 or exclude 9. If I include 9, I get 20. If I exclude 9, 11 as it is. Now here we have got the first solution. This way if you solve it, you get the solutions. No need to draw the entire state space tree. Draw the partial state space tree in which at least one solution is indicated. This much is okay. Thank you.